Hey guys, it's Miss Messer here, and I'm going to show you today how to factor a polynomial by using the greatest common factor. So first I'm going to review what is the greatest common factor, and we're going to look at binomials and trinomials today. So I'm just going to show you what that looks like as far as pulling that greatest common factor out of two terms and then with three terms. So we'll start off real basic here. If I've given you 14 and 24, for example, and I wanted to know what the greatest common factor was between those two numbers. And some of us can look at this and pull that greatest common factor out, and some of us struggle a little bit depending on how well we are with our facts. So what we do is I call this upside down division. And if you notice, both of these numbers are even, and so we can definitely find an even number, or we know that even numbers are divisible by 2. So I can divide this by 2, and when I say 14 divided by 2, I get 7. And 24 divided by 2 is 12. And when I take a look at those two numbers, 7 and 12, they don't have anything in common. So I'm done trying to determine what my GCF is. So 2 is my greatest common factor. So let me take a look at another example. Let's do 60 and 90. So when you take a look at these two numbers and you're not sure what the greatest common factor is, you can just start dividing by any common factor that both terms have. And again, you could say, well, these two are even, so I can divide by 2. Or you can say that they both end in 0, so I can divide them by 10. Or they both end in 0, so I can divide them by 5. It's just whatever method that you can think of. Those are little shortcuts. If they're even, end in 0 or 5, we can divide them by 5. If they both end in 0, we can divide them by 10. So I'm just going to jump straight into that bigger number, which is 10. Ends up creating less work in the long run. So 60 divided by 10 is 6, and 90 divided by 10 is 9. Now if you notice, 6 and 9, they have a common factor, so I can divide this again. And 6 and 9 both can be divided by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. That 2 and that 3 I can't do anything else with. They don't have any other common factors besides 1. So at this point I'm done, and I would take these two numbers on the outside and I would multiply them together. 10 times 3 is 30. So the GCF for 60 and 90 is 30. All right, so that is a previous concept from probably 4th or 5th grade. So now what we're going to do is we're going to beef it up a little bit. We're going to take a look at when we have variables like 15x squared and 30x cubed y to the 4th. And so again, if you're not sure what the GCF is between 15 and 30, you can do the upside down division. And some of you guys are like, oh, 5 is a common factor. So 5 goes into 15 3 times, and 5 goes into 30 6 times. And I could divide that again by 3. That would give me 1, and 6 divided by 3 gives me 2. So 3 times 5 are my outside numbers here, so that would give me my GCF of 15. And you might have looked at that 15 and 30 and knew right away that 15 is the greatest common factor. All right, so knowing that, I also have variables, though, that I have to look at. So what you want to do is take a look at each of the terms, and they both have an x, which is a good thing, and one's a squared and one's a cubed. So I would want to take the one that's got the smallest exponent, which is the squared. So that would be x squared. Then I would do the same thing with the y's. They both have a y. This has an invisible 1 for the exponent. This one has a 4. So the smallest one is y to the first power. So I'm just going to use the y. So this is my greatest common factor. So if you have variables, make sure you take the variable that has the smallest exponent. And the GCF is only if they both have that variable. So if I had 3xy squared, and I'm not going to do any binomial stuff yet, and I had 12x squared. So again, to find that greatest common factor between those two numbers, I can do upside down division. And so I know that the biggest number that goes into 3 and 12 is 3. So I don't have to do my upside down division unless you just wanted to double check. They both have an x. This has an invisible 1 and this has a 2. So the one that's the smallest is the x to the first power. If you notice, this first term has a y. This second term does not have a y. So I cannot say that they have a y in common because they don't, and therefore I can't use that as the GCF. So this is my GCF, 3x. You can only take the variable if they both have it. All right, so knowing that, that's the GCF, now we can actually factor. So this worksheet is the worksheet we did in class today, and it's attached in your email, so that way you can either print it if you have that option or work these out on notebook paper. The first 3 problems that you see are just a review of what we did last unit. So here we are going to distribute. So this gives me 3a squared plus 7a. And what we're going to do today is we're going to actually start with this on the right-hand side, and my answer is going to be that with the parentheses. So we're actually going to be working backwards. So factoring is working backwards from what we did last unit. Again, another review here. We have a monomial times a trinomial, so I would multiply the coefficients, add the exponents. Multiply the coefficient, add the exponents. Multiply the coefficient and add the exponents. So that's just a review of what we did last week. 5x squared y minus 10xy squared. And so today, like I said, we're going to start off with problems that look like these on the right, and we're going to end up with parentheses. And that method is called factoring. So what is factoring? This is a process, or it is the process of separating polynomials back into a product. And so our answers are going to have parentheses today, whereas last week we were trying to get rid of parentheses. Now we're going to be putting parentheses in. Polynomials that cannot be factored are called prime. It's a rare occurrence, but it does happen. As a matter of fact, on this worksheet, there's only 1 problem out of all 24 that was considered prime. All right, so there's several ways to factor. The approach we will take depends on the polynomial. Today we were going to start by using the greatest common factor of the polynomial, and then we'll talk tomorrow about difference of squares, and then we will do trinomials, and then we will talk about 4-term polynomials. So it depends on what type of polynomial you have, depends on what method you'll use to factor it. All right, so how do you factor? What you're going to do is you're going to find the greatest common factor. So first do the coefficient, the 3 and the 12. And if you need to, you can do the upside down division, that little trick that I just talked about at the start of the video. Or hopefully at this point, you know that 3 and 12, the largest number that can go into both is a 3. And just remember that your greatest common factor can never be bigger than your smaller number. So I couldn't say 4 or 5 or anything like that. It has to be 3 or smaller. So after I've decided that 3 is my GCF, I divide both terms by 3. Now you're probably wondering, what about the x? Well, this term doesn't have an x, and so they don't have an x in common, so I can't use an x in my GCF. So the only GCF I have is the 3. So I'm going to divide by 3. And you remember, we divided polynomials by monomials already, so this looks very familiar. We know how to do this. All you do is you take each term and you would divide it by that denominator. All right, so you take this GCF. This is the only different part than what we've done previously. You take that GCF and you're going to put it on the outside of the parentheses. And when you divide, that all goes inside. So 3x divided by 3. So we're going to take this first term and divide it. 3x divided by 3 is 1x. You don't have to put that 1 up front if you don't want to, but it is understood to be there. Then you're going to take the 12 and divide it by 3. So 12 divided by 3 is 4. And that's your answer. An easy way to check your answer is you can distribute. 3 times x is 3x, and 3 times 4 is 12. So you end up with what we started with. Isn't that cool? So you just have to remember to divide by the GCF. Make sure you put that GCF on the outside of the parentheses, and whatever you get after you've divided goes underneath of the, inside, the parentheses. I was talking while I was writing. All right, number 2, what is the biggest number that can go into both 7y and 7? If you said 7, you are correct. They both don't have a y, so I cannot put a y on the bottom there. So my GCF goes on the outside of the parentheses. So I'm going to divide 7y divided by 7 is 1y. Again, you don't need the 1 in the front, but if you put it there, that's fine. And then we're going to say negative 7 divided by 7. Negative 7 divided by 7 is negative 1. And that's my answer. Again, you can distribute to check your work. And that's all we did today. Now I do want to jump down when we start getting multiple variables here, like on number 7. So both of my terms, I first focus on the number, so 21 and 3. What is the number that I can divide into both 21 and 3? 3. If you notice, this term has a C, this one does not. So I can't say that they have a C in common. However, they both do have a D. So I can take out a D. I can divide by D. And they both have a 1, so the smallest exponent is a 1. So just a 3D is what they have in common. So when I go to divide, remember to put your GCF on the outside of your parentheses. So now when I divide 21CD divided by 3D, you divide the big numbers and subtract your variables just like before. So this gives me 7C. The D's would cancel. Then I'm going to take my 3D and divide it by 3D, and so I get negative 1. The D's cancel. And that's all you got to do there. Divide by your GCF. One that the student struggled with, we'll take a look at number 11. There are no coefficients, so I don't have to worry about determining the number. I just have to look at the variables. So if you notice, they both have the letter A, and so I can divide by A. Can't divide by B because they don't both have it, so they don't have it in common. So A goes on the outside. AB divided by A is B, minus A divided by A is 1. So just remember to divide each numerator by the denominator. That is how you factor out the GCF. So if you will, you have a copy of this worksheet in your email. If you would open that up, and then you can work out these other problems. On the back side, let me show you some problems on the back. You get to see that there are some trinomials here, but we're only going to be looking for the greatest common factors. And again, down here at the bottom, there's a recap for finding the GCF of a polynomial. You always want to look at those coefficients first. And then you want to see if there's a variable with all those terms. And if you do, you want to take out the smallest exponent variable. Once you've determined your GCF, you're going to divide all terms by that GCF to get the remainder in the parentheses. So let's take a look at one of these trinomial problems. Let's just look at number 18. Number 18 has a lot going on, but these are fun. So if you want, or what you should do is look at the numbers, not that you want to, but look at the numbers, and I just ignore the negatives for now. We'll talk more about negatives later. But right now I've got 12, 36, and 6. I know that my GCF cannot be any bigger than 6, so I'm just going to start by 6. Let's see if 6 will divide into each of these. 6 goes into 12 2 times, 6 goes into 36 6 times, and 6 goes into 6 1 time. And now if you notice, all three of these, they don't have anything else in common. So my GCF is a 6. So what that means now is I can underline this, write down my GCF of a 6. But I also have some letters I got to look at. So each term has an A. That's a good thing. So which one has the smallest exponent on the A's? I got 5, 4, and a 2. The smallest one is the 2. So I'm going to put down this A squared here. And you want to do the same thing with your B's. You got a B squared, a B cubed, and a B squared. Which one's the smallest? B squared is correct. So if they all have A's, take out the smallest exponent. If they all have a B, take out the smallest B. All right, so now I'm ready to divide. Don't forget, put your GCF on the outside of your parentheses. So just like before, we're going to take each term in the numerator and divide it by the denominator. So 12 divided by 6 is 2. Subtract your A's, subtract your B's. Minus 36 divided by 6 is 6. Subtract your A's, subtract your B's. And last, you have negative 6 divided by 6 is 1. Subtract your a's and subtract your b's. I didn't have any left over, so this is my answer. All right, so if you would, finish those problems for practice. Let me know if you guys have any questions on finding the GCF and factoring the GCF out. And I will see you guys again soon. Bye now.